Yeah, so I'm excited to be back here. I think that I was a speaker at the first one and the third one, but the third one sucked because I was remote. But yeah, so this is my third time here. Yes, because they do suck. Am I allowed to say that on camera? So one of the things that I was thinking about when Keith sent the email about the topics that we would like to have a conversation with is what to talk about. So I have a couple. I like stuff. So and I like to talk. So put two and two together. I have a couple of choices, but the first initial knee-jerk reaction was, let me find something that I can go tacky stuff, right? Let's go really, really deep. But then Keith threw a curveball saying that the long sessions are 30 minutes. And to his point, it's a difficult thing because you have to compress to the essentials. So this presentation will be RSSI revealed, but a little, right, sparkle of marketing on top of it, or whatever you want to take it. The important stuff is what I really want you to take away, or what do I expect from all of you guys to learn and take away from this presentation is, yeah, there's nothing happening here. So if you're waiting for an animation or anything, there's nothing practical that you will get away from this stuff that you can implement directly, right? Plus, I was looking at my email box yesterday and there was this. So if anybody wants to learn about signal strength and everything, MetaGeek has a blog roll and a couple of learning blogs, and it's there, right? So if you want to learn how to implement, how to use the signal, how to read the signal, everything is up there. So instead of going to the practicals of the presentations, I'll go to the motivation behind it. So what I really want to get out in terms of messaging with the presentation. Number one, I picked this topic because, hey, I like it. I like to learn stuff. And the stuff being technology or otherwise, I just have that initial drive to understand how stuff works. Sometimes it has practical implementation, sometimes not so really. The second thing is, you will know or be aware of most of this stuff, but maybe it will connect the dots to the best practices. There is a reason why we do certain stuff in a certain way, and hopefully we can connect the dots into why. The third one, which was a major challenge for me over the years, it's getting a little bit easier with me being in the marketing, but that's the abstract thinking. Right? So just thinking beyond the two dots, so finding the third dot or trying to colorate something that doesn't have the apparent connection. The fourth thing is to embrace, and that's a spoiler, so I'm not gonna go there, but there's a spoiler. And the fifth thing is, again, hopefully that nobody in this conference is using this, but there's still a lot of bad practices involved with RSSI all over the place. Yeah, so there's that. So let's go to my thinking process. So in terms of the RSSI, the way that I learn stuff, it's like a campaign. Every once in a while, you have this revelation, you go back and you see things from a different perspective. And so I kind of slotted my progression, learning about the RSSI in the 5 stages. And now that this applies to me, there is no such thing as 5 stages of learning. This is just how I see this. And the stage 1 really does not begin with me learning about Wi-Fi. This is still when I was, like Blake said, where's Blake? Hey, wake up. Yeah. When I was still in the field, right? Doing the great stuff, being passionate about, hey, there's something special that I've built and nobody else does, so I'm the king of the world. And I was just thinking now, being the Olympics, right? Thinking back, it's now 8 years that I was sitting in a car, driving 50 miles an hour, watching the skiing on my laptop using Wi-Fi. That was 8 years ago, and I was the king of the world. So this is where my my travel, this is where my path starts. And right about now, I think that there's stage 4 that I'm there. I have no idea how more stages there are, but it's a path. So I will take my learning about the RSSI, and let's go through this path. So the first one is, right, I'm the king of the world. I've read the Coleman's books. I read Matthew Gass' books. There's progression to the CWNE, but I need to understand what RSSI is, because what I'm looking in the field is not what I'm expecting. I need it to be more. I need to understand why is it not more, right? And the answer to me was, right, the Bible. So let's go and open the standard, right? Because surely there's there. So I'll be just boom, I'll find the answer, I'll understand it, and right, I'll just, there it is, the Holy Grail. Now the example here is the latest available standard. I wanted to put the AX in, but Perry would kick me in the ass if I put that. So I just put the latest available standard that you can get. And the way that I learn is I cannot do it linearly. So if anybody reads the standard, if you read it like from top to bottom, hats off, I cannot do it. Right? The first 200 pages is just indexes and whatever. So being smart, you just open it in a PDF. There's a right-hand side box. It's a search box. You type in RSSI. Right? So let's go. And the first things first, right? RSSI, Received Signal Strength Indicator. Okay, so we're on the right path. The second one, RSSI, okay, it's an integer, and there's a valid range from -1 to RSSI. What are they talking about? It should be a power, and then indicates that the station is not present. I'm not interested in that. I'm interested in RSSI in Z power, so you dig deeper. So there's, what's this? Data frame RSSI. I don't know what RSSI is in the first place, let alone what the data frame RSSI, and you dig, and you dig, and you dig, and you dig. And eventually you start connecting the dots, and you get with some stuff out of it, and I did learn, I did have a couple of revelations, but the most important now, seeing back and looking back at the time, is the clues that are dropped in terms of like, there's a word here, word there. And the clues, right? Indicator, integer, RCPI, dynamic range, monotonically increasing function, and all of that I had no idea what they have in a relation to the RSSI, but it's there. But in terms of the conclusions, and again, these are my conclusions, this is how I learned, there is a couple of practical things. Number one, RSSI and where it's measured on the preamble. Preamble has a different modulation than the things that we actually care about. Hence, the power is different. So whatever you see in the RSSI being on the preamble, it's not what it's actually in the data frame or what's in the trailer after the preamble, because that is dependent on the modulation that is being used. Which was interesting, right? Because when you're looking at the parameter, which is predominantly static, whatever frames that you're using, regardless management control planes, whatever, you're looking at the phi. And that kind of made sense. Started me thinking, okay, how can I use this? And also started me to think beyond what can I actually control. There was a good presentation that I agree a lot with from where's the emperor? Yo. But one of the point is what we can control power. You cannot control power in Wi-Fi, right? So what you can control is the maximum average power that you can get here. This is dynamic. You can implicitly control it by bringing the access point next to the clients. And this is where it ties back together to those best practices. So you want to have access points next to the clients because this will get better. It will not help with your CCI because that triggers it, but it will help you with being faster on and off, so you'll have more room for everybody else, right? So when you start connecting the dots. Stage 2 conclusion was, there's this RCPI being mentioned all over the place, and we're not using it. And if you look at the date, top right, 2003, where the improved metrics were suggested, that's a while back, right? So it was mind-baffling. So if RSSI is what it is, and it's ill-defined, and it's just lacking, why don't we have this? So my conclusions was, okay, I understand what it is. There's the dynamic. There's a delta of acceptable what client does. The RSSI is not a static value. So when you're doing anything, that's why you pick the worst client, because that would be your lowest common denominator. And also understand whatever client that you pick, there will also be a delta in between the same client set. So test those as well. And once you're testing, make sure that whatever you're testing with, you can also periodically sanity check. Like if you have a NIC that you like to do your wireless service with, have to keep one at the desk, survey with the other, measure the delta in between them, and over time measure again if that changes, right? So all of this type of stuff helped me to understand better the principles and the best practices, not so much with the RSSI, but the thing is, don't rely on the RSSI and stupid vendors and stupid IEEE because they're not doing things better, right? So this is my stage 1. So then, stage 2, because I was not happy with this, right? So I was content that the IEEE is not defining this beyond what I thought was a reasonable, acceptable answer for me, so I wanted to dig deeper. So the way to understand where the deeper is and where to look at is just starts from the beginning. So from the high-level perspective, and you have a signal emitting, you have a signal being received, and I was just trying to trace that signal. And then you open up and you start learning about the radios, and you get the high-level physical, logical things, and you get the signal in, and you get into the components, and then you can start understanding each of the components. Well, as it turns out, the power measurement, it's a bypass of an other function, but we're using it to measure. But then I had to measure what's the front end, what's the modulator, what does it do with anything, how much the antenna impacts. And oh my God, that rabbit hole starts to go deep. And the problem is, it's not just one hole, it starts separating into different holes, right? But okay, let's go ahead. I wanted to know more about the measuring. So what's the actual, it's talking about the RSSI, and it's talking about the signal coming in, but it's not talking about how do we get the data, right? So I started dissecting this. So there's a lot of math involved. There's engineering, so the practical implementation of all of that, and the processes, and they're not three distinct things. They interact with each other, and you can go deep in any of those, right? As an example, this is just a couple of screenshots of the math used by just collecting the data. And the data collected, once you go in, there's a lot of processes, repetitions, error corrections. It just goes, right? At least it was too much for me. So then I said, okay, let me try. I dig that there's smart math guys. What about the processes? So the process would be then like this, and don't read it if anybody wants to have the example of this, but this is the process of certain measurements being made over the time, at the time of that specific measurement, and all of these fields would input into the math being there, hopefully sometimes ending with a measurement, which is the RSSI. And then just how the whole is like digging the whole examples if you want to learn about just the engineering, the implementation of these things, right? So this is an example of the power meter, right? So on the right-hand side, you have the probe, which would be the thing that you're measuring. You're going into, and it's pretty simplified, right? Different resistance, so you can extend the range of the power that you're using. You amplify it because we have a very low signal coming in. So in order to measure the signal, you have to amplify it, and then you collect the data. And power measurements can be easy. By the way, I really enjoyed this presentation. I think that was one of the highlights for me. So good job on the presentation. Well, the thing with very low power collection, however, is it's not as easy as measuring the voltage. So the first thing that I learned is that you have to rectify the signal coming in. You rectify it to the DC. So you're measuring the DC. And the way that we can measure the DC, and that's the rectifier. So the way that we can measure the DC, there's numerous ways. From being able to measure the difference in the temperature being made, and then I've learned that this is really not used in Wi-Fi because Wi-Fi is so quick that this will not be able to adapt, and then you have a better version of the same thing. You end up with learning, actually it's the diodes and semiconductors being used. So, but it's just digging deeper, digging deeper, digging deeper. Oh my God, so then I was kind of glad that they didn't expose this type of stuff in the IEEE, and it's already like 3,000 pages long, right? So, but again, it's a learning process. You learn stuff. And there's a couple of things that I have learned. The number one, the hole is deep, right? I haven't found the rabbit yet, so I don't know where he is. But I've learned that the power meters that we are using to measure Wi-Fi are only confidently measuring the power up to a certain degree, right? You have the difference in between the diodes being used, the difference in between the material, the difference in the implementation, because you also have to shield from external things that you don't want to measure, like WSWR or like the implication of powering the board in the first place. So all of that is included in the IEEE definition. This is why we expect you to do plus minus 5 dB, which is pretty wide range. But the most important thing is actually the values, whatever values you provide, and they're not accurate, they should be linear, which was another clue, right? There's lots of mathematics involved, lots of computations, still stupid vendors. This time I'm whispering because I'm working for one of the vendor. But it just gave me a little bit more insights. And interestingly enough, we do have a way to measure more accurately with spectrum network or vector signal analyzers. And you've seen the boxes, they can be really expensive. But most of the modern Wi-Fi chipset do have the ability to do the spectrum analysis to a point. It's just not used for the RSSI in most cases for now. So, but as I was digging, there were new clues. Accuracy, precision, scalability, semantic technology, that's a big one. Computational expensive filtering, reuse, CPU limitations, and on and on and on, which kind of propelled me to start looking at the other direction. Okay, so I've tried to dig in the hole, but let me try to find the rabbit on the ground, moving up. So stage 3 up the stack. Right, so I couldn't find the rabbit, but there's a cat for you, so let's take a second to enjoy the picture. Okay, so up the up the stack. The RSSI being whatever it is, it's an integer, and don't read this, it's just focus. The RSSI being displayed is not accurate, number one, but it's linear. It's an integer and it's linear, which means that you can still do stuff with it, right? Because you can append it to whatever you want it to be. And you've all heard examples from Adrian, right? Agent collects the data, and based on what he feels that data means, he implements it. So there's a kind of a feedback loop, and this feedback loop can happen anywhere. It can be either on the radio board itself. There's a lot of computation that is being done right in the hardware. And if you have like an ESDK to the radio board, you can use the RSSI and all of that to start programming the algorithm that you want to do for dynamic rate control or any other aspects that includes the RSSI. But the thing is, you're using an integer, whatever that is, and you're connecting it to something that you expect it to be. Right? And that's the Holy Grail. Or you can do it up the stack, like in a kernel level or in the app level, where you are just combining, analyzing the RSSI with whatever you want it to be. Example, whips, triangulation, whatever, right? So there's this type of information is scarce. It's provided on a different level, like the driver level when you're buying things like from Texas Instruments, or you're buying from the chipset driver, you will get X amount of information. For the access points, nobody from the vendors, we don't expose this. So you don't see it. But one of my favorite things, not necessarily in order to see how it works, but how people use it, is the open source community. So from like Mad Wi-Fi drivers, I always forget, which expose certain logics that they use to like OpenBSD or FreeBSD, where you can just browse the code and learn, okay, David implemented this way. And it's pretty interesting read when they have like a community interacting with each other. What does this mean? What does this mean? Oh, but I got this value. This doesn't make sense. Yeah, so let's just normalize it. So let's just put an exception, another loop. So if you're in the range here and here, the value should be right about there. So they're doing their own corrections as well. And it brings more chaos, but also brings a lot of possibilities, right? So conclusions. RSS implementation does provide some benefits because it all of a sudden becomes to be a tool beyond just the measure of the power. Tracking those implementation is pain in the, right? And I need to learn how to code to show them how it's done. So that was my thing. And by the way, silly developers, right? So that was my conclusion number 3. Number 4 is where the pieces started coming together. If you think about the technology, we are always talking about OSI level, right? How things are falling together, and you have the physical layer and whatever. And I've always kind of imagined it like this. You have distinct different levels, and then you connect them in between, and they're Lego blocks. So once you connect all of them together, you have a solution. And RSSI could be one of the Lego blocks connecting in between the two. Well, this is not how it looks. How it really looks, it's more like this. You have the blocks, and you have the anchor points, which would be those interfaces, and you have the rubber bands connecting those interfaces, right? So there are standards of the implementation, making sure that the rubber bands are of a certain standard, so your fraction, your movement will be at acceptable level. And it's acceptable because rubber bands are cheap, which is why the reason why Wi-Fi is successful, right? It's available, it's cheap, it's relatively easy to use. It's a multi-billion-dollar industry, and we're still complaining that the RSSI is bad, but so it works, right? And the power is that it's not with the rubber bands that you can only connect the layers, but you have the ability to implicitly strengthen the layers from the upper stack, right? So imagine whips or triangulation or whatever. It's not the Mac layer or the CPU deciding that things. It's some application above. And it can normalize the data. It can make it more accurate. It can use other data point to make that more accurate, and you put it together. So you end up with a nice stack. So the more that I dig is not necessarily that I've came to the end, and I said I didn't find the rabbit, but I did find additional admiration, not just to the 802.11 as implementation and the complexity it provides, but the way it is designed to be as a framework so it can expand and support all of the businesses that we can see, right? And it's enormous. So if you think the implementation of the stacks, and you go in there and you connect all of the dots so you get nice solution, that works. But where it really starts blowing your mind is think beyond, right? So you have a fluffy cloud up there, so that's my interpretation of the cloud, and it can be anything, right? It can be computing on a different computer, it can be cloud, it can be whatever, but come on, that was a spoiler. You didn't see that. Okay, but the idea is that with the things like RSSI and the methods like mathematics, like analytics, like heuristics, now we're going into AI, big data, all of that, and it's amazing what you can do with the information like RSSI that we know from the beginning. It's just an integer. It doesn't mean anything, right? And if you already do so, great. If you don't, I really encourage everybody to listen or to read more scientific papers. There's, based on the industry motivation, there's spawn research. So you will find a lot of research being done on proximity, on locationing, on moving, on making those things together. And it's amazing what they can do with this. Everything has a cost, right? The computation is money. The more computation you need, the more money you get. The big data has its, but you can get amazing stuff with, again, the rabbit hole, not a rabbit. It's a hole. So yes, come. There is no spoon. And so and that's the right now. So I started being so focused on I hate everybody because RSSI it's not what it's supposed to be, to oh my God, they're genius because it allows me to do so much. Shaming time, and it's not really shaming time. One thing that I'm still disappointed, and I'm from marketing. The things that I say and do, there's a buffer in between, right? So people can say that I am lying sometimes or selling or whatever, but even I have a line, right? And the line is, don't use RSSI as a quality metric to anything. Right? And you would think that over the course of 21 years of Wi-Fi that people would start appreciating this, but there's enormous implementations like from multiple services providers to communication saying, look, I have green good, green better than orange from that guy, right? So just come on, don't do that. What I would suggest actually is, yeah, you have education part, which would be like a carrot that's a long-term and a more successful way, but you also have the stick part. So Ekahau, IBWave, Tamosoft, whenever people export something which has just an RSSI as a value, append a link to educational material to what RSSI is, so if somebody wants to give it to a customer, they would have that in the face. Thank you.